So far we have learned how to build, add, multiply, and divide polynomials. Today we flip the problem around. Given a handful of points, how do we find the one polynomial that passes through all of them? This is Lagrange Interpolation, and it's the exact mechanism that turns a ZK circuit into a single polynomial. The problem: given the points 0, 1, 1, 2, and 2, 5, what signal polynomial passes through all three? With 3 points, exactly 1 degree to polynomial fits. The trick: basis polynomials. The trick is to build a small helper polynomial for each point, called a Lagrange basis polynomial. Each one is designed to equal 1 at its own point and 0 at every other point. Build a helper L sub I of x for each point. L sub I of x equals 1 at its own point and equals 0 at every other point. Each one only turns on for its own point. Building each basis polynomial. For our three x values 0, 1, and 2, here's how each basis polynomial is built. L sub 0 of x equals x minus 1 times x minus 2 over 0 minus 1 times 0 minus 2. L sub 1 of x equals x minus 0 times x minus 2 over 1 minus 0 times 1 minus 2. L sub 2 of x equals x minus 0 times x minus 1 over 2 minus 0 times 2 minus 1. The denominator is fixed. The numerator has an x minus point factor for every other point, combining into one polynomial. Now we combine all three basis polynomials, each scaled by its point's y value, and add them together. P of x equals 1 times L sub 0 plus 2 times L sub 1 plus 5 times L sub 2. Check x equals 0. Only L sub 0 turns on, giving 1. Matches. Check x equals 1. Only L sub 1 turns on, giving 2. Matches. Checking x equals 2. Only L sub 2 turns on, giving 5. Matches. Expanded out, this whole thing simplified to P of x equals x squared plus 1. The general formula. This generalizes to any number of points. Just sum each point's y value times its own basis polynomial. P of x equals the sum over I of y sub I times L sub I of x. This works no matter how many points you have. Why this matters for ZK? Here's the payoff. In a QAP, the structure behind growth 16, every gate in your circuit becomes a point, the gate's index and its value. Lagrange interpolation takes all of those points and produces a single polynomial representing the entire circuit. This is literally what the Q in QAP stands for: quadratic arithmetic program.